Okay, so all that we've been doing up to this point is naming ionic compounds. We looked at naming monatomic ions, and we looked at naming binary compounds, right? Things with two elements. So today we're going to take that a little bit step further. We're going to start working with our polyatomic ions, and we're going to start working with those elements that have multiple charges and how we differentiate between which of those versions of the element is being used. We're going to deal with multiple charges, okay? But you need to understand that an ionic compound is naming this system, right? Using a cation, then the anion ending in IDE. It's always between a metal and a nonmetal. It always has a cation and an anion. Okay, so if you are given a compound and you have to decide if it's an ionic compound or a covalent compound, which we're going to talk about next week, this is your clue. Ionic compounds are metal and a nonmetal. Okay, that needs to be like drilled into your brain. Ionics are metals and nonmetals. Okay, so I want you to take a look at your periodic table of ions, and I want you to take a look at those transition metals that have multiple charges. Okay, and we're going to look at some of these multiple charges and see how that affects the way that we name things. Okay, so let's take a look at this. I want you to name this compound lead. Sulfide. Lead sulfide. I want you to give me the chemical formula for lead sulfide. So right off the bat, we should have a problem, right? And what's our problem here?
Lead has two.
Lead has two charges, so how do we know which charge to use? Because that's going to give us two different chemical formulas, right? If we would use lead plus 2, and we use sulfide, which is minus 2, that would give us a compound that looks like this, PbS, right? Because we're going to take the 2's down, and then we reduce those. We don't have Pb2S2. Like we would reduce those down to the smallest common denominator. On the other hand, if we use lead plus 4, because that's the other option that we have for our Roman numerals, lead plus 2 or lead plus 4, and we use sulfide, which is minus 2, that's going to give us a different compound, Pb2S, right? Those two things are very different. They behave differently, they are shaped differently, they're made up of completely different number of atoms. So those are different compounds. So that just goes to show that the charge or the type of lead that we are working with makes a difference, okay? Okay, so when we cross our charges down, we're left with Pb4S2. So we can reduce these subscripts to a 2 and a 1. Oh, yeah. My fault. That's what I get for going too fast. Okay, so we're going to have PbS2. Right? Because it would be 2 and 4, and then we reduce those. That makes sense. Thank you, Jenna.